Hello students. In the last class I have discussed with the second order time response derivations. Now we'll start with the transient response specifications of a second order system. So in that we need to discuss some time domain specifications. So the first one is delay time. So notation is TD. So what is the definition of TD? Time required to reach 50% of the final value of in the first attempt. So equation for that TD will be 1 plus zero point 0.7 zeta by omega n seconds, where omega n is the undamped natural frequency, so radians per second, and zeta is the damping ratio. Second term or specification is rise time. Its notation is TR. It is defined as time required for a response to rise from 10% to 90% of the final value of for an overdamped system and or 0 to 100% of its final value for underdamped system. So in general, we will take this one 10% to 90% for overdamped systems. So equation for that TR will be rise time will be pi minus theta by omega d seconds, where theta is in radians, omega d is a damping frequency. So next term will be peak time. So notation is TP. It is time required for a response to reach its peak value or time at which response undergoes the first overshoot, which is always peak overshoot. The equation for TP will be pi by omega d, which is equal to pi by omega n under root 1 minus zeta square seconds. So where omega d is damping frequency, that is which is equal to omega n under root 1 minus zeta square. Next term will be peak overshoot. Notation of this one peak overshoot will be MP. So it is defined as it is the largest error between the reference input and the output during the transient period, which is given as MP is equal to C of T at T equal to TP minus 1. So usually peak overshoot is expressed in terms of percentage. For that peak overshoot, we have the expression as percentage MP is equal to e raised to minus pi zeta by under root 1 minus zeta square into 100. This equation is very, very important. So next point is or next term is settling time. So its notation is TS. The time required for a this response to decrease and stay within the specified percentage of its final value. So time constant is now defined as T is equal to 1 by zeta omega n. We have Ts equal to 4t. So therefore, so settling time, that is Ts, is given as 4 by zeta omega n. So therefore, these are the some different terms, transient response specifications of a second order system, like delay time, rise time, peak overshoot, settling time. So these are some very important terms involved in the time domain specification of a second order system. So move on to the here pictorial representation or graphical representation of these terms. So you can observe here, this one TD is the delay time, which is time required to reach what 50% of the final value. So you can observe in the graph, it's a C of T versus T. Next rise time, which represents here, it's a 10% to see 90% of its value. So this is the rise time, what we can call it as. Next TP. So this is the TP time required to reach its first peak overshoot, means maximum peak value which is at its first attempt. That time duration is called TP, that is peak time. Settling time means output at which reaches 98% of its final value. So it will be TS. Remember from this diagram, we can easily say that TS is always greater compared to all the time durations. So this is minimum understood, right? This is of the graphical representation. Next, I will move on to the derivation of these terms. How exactly the final equation of these terms will look into. So that we are going to now discuss. So in that, the first one is what? Peak time. Just now already we have discussed what exactly this peak time. It is time required for a response to reach its peak value or a time at which undergoes the first overshoot, which always peak overshoot. We have a time response of second order system. We have this equation, that is C of t is equal to 1 minus e raised to minus zeta omega nt by under root 1 minus zeta square sine omega dt plus theta. So we call that this equation as 1, where theta is tan inverse of under root 1 minus zeta square by zeta. For maxima theorem, we have the concept of maximum value, right? So that is differentiation of a particular variable at peak value. So that results in 0. So similarly, we have d by dt of c of t at t equal to tp is equal to 0. So differentiate this equation number 1 with respect to t. So now here differentiation of 1 will be what? 0. So now differentiating these terms, second term, so using product rule, so that we are following minus e raised to zeta omega nt as it is, and differentiation that will be minus zeta omega n sine omega dt plus theta as it is, divided by under root 1 minus zeta square as it is, minus e raised to minus zeta omega nt as it is, differentiation of this sine term, so that is cos omega dt plus theta. Differentiation of this omega dt results in omega d. So divided by under root 1 minus zeta square, that is must be equal to what? 0 as per this theorem, maxima theorem. So next, upon simplifying, since omega d equal to omega n under root 1 minus zeta square, that you substitute here. That is the one thing. If you upon substituting that, so this term, so omega n and this omega n will get cancelled. E raised to minus zeta omega n, this e raised to minus zeta omega n will get cancelled. So next, that left out term will be what? So zeta here and sine omega dt plus theta. That term you have written here. Minus under root 1 minus zeta square cos omega dt plus theta is there, that we have written, is equal to 0. Now we'll take these sine and cos separately. So if I take sine this side, so after substituting these terms left hand side, so sine by cos will be what? Tan omega dt plus theta. So under right hand side we'll get under root 1 minus zeta square by zeta. We know this one. Now if you want tan theta, so we know that tan theta will be under root 1 minus zeta square zeta from the damping ratio triangle, right? So therefore we can write here, since tan n theta plus theta is equal to tan theta, so omega dt is equal to n pi. So for all values of n positive integers, so but tp is calculated for the first peak, so that is n equal to 1. So put n equal to 1. So therefore omega dt tp is equal to pi. We want tp, right? So peak time, so peak time tp is equal to pi by omega d, which is equal to pi by and omega n under root 1 minus zeta square seconds. So this is what the required expression for peak time. So that is Tp. Next, move on to the next term, peak overshoot. Right. So how we should calculate this peak overshoot? That we are going to now concentrate. So it is defined as it's the largest error between the reference input and the output during transient period. We can observe the graph here. It's a CT versus and T. So where the response is oscillating like this. So this height MP, this is what the peak overshoot at T equal to TP. We know MP is equal to the C of t minus 1, means C of t is up to this point. We should subtract this one, unity 1, right? So that to get MP. So this is what the CT term overall. So minus 1, that this results in what? MP, right? Now, substituting that, this plus 1 and minus 1 will get cancelled. Only terms will left out is what? This one. E minus e raised to minus zeta omega n tp under root 1 minus zeta square sine omega dt tp plus theta. So we have tp equal to pi by omega d from the previous derivation. And also we can write Tp omega d is equal to n pi, omega d Tp is equal to pi for n equal to 1. So further we can simplify this one as mp is equal to minus e raised to minus zeta omega n Tp divided by under root 1 minus zeta square sine pi theta. Why? Because n is here 1. We know sine pi plus theta is minus sine theta. So substitute this one back here. So we'll get this minus sign and this minus sign will get cancelled. So that results in plus. So therefore e raised to minus zeta omega n Tp whole divided by under root 1 minus zeta square sine theta. From damping ratio triangle, we have sine theta equal to opposite by hypotenuse. So therefore under root 1 minus zeta square divided by 1. So therefore mp is equal to e raised to minus zeta omega n Tp whole divided by under root 1 minus zeta square into under root 1 minus zeta square. This will get cancelled. So mp is equal to e raised to minus zeta omega n Tp. But we know the value of Tp. What is that? Pi by omega d. Substitute that. So we'll get here. So in the place of omega d, you substitute omega n under root 1 minus zeta square. So therefore this omega n will get cancelled. So mp will be which is equal to e raised to minus zeta pi whole divided by under root 1 minus zeta square. So mp can be expressed in the form of percentage. So usually, so you can write percentage mp is equal to e raised to minus zeta pi under root divided by under root 1 minus zeta square into 100. This is how we are finding the expression for what? Peak overshoot. Rest of the things we'll discuss in the next class. Thank you.